All right, class, your attention up here. Walk around the room, looked at some good answers, looked like some good stuff. Saw a little bit of frustration, that's okay. Trying to remember what we did. These first two problems are just application problems of the stuff. Actually, they're not even applications. They're literally just the stuff that we did yesterday, just reminding you how to do that, okay? So we want to hit this before we look at some new problems, and we'll talk about all that here in a moment. So let's go ahead and knock these out really quickly here. So all they're asking us for is to find the missing sides, okay? They say in the first two problem, we've got this 45, 45, 90 triangle. They give us the length side, length there of 7. They're looking for the 8. Something I would recommend when you've got these problems, draw the special right triangles in the same orientation. So for instance, I drew the 45, 45, 90 right here, x, x, x root 2. If this is a 7, what's this side over here? What's that leg going to be?
7.
Also 7. And the hypotenuse? Anybody?
7.
Yeah, be strong.
7 root 2.
7 root 2, there it is. 7, 7, 7 root 2. Okay? And now over here, the 30, 60, 90, I drew the special right triangle, the 30, 60, 90, in that same orientation. Across from the 30, I drew the x. Across from the hypotenuse, the 2x. And then here across from the 60, the x root 3. If you notice here, they gave us, this is the advanced problem. The hardest one that they could give you when it's the one the side across from the 60. Okay? Now there's a couple different ways that we could attack this, okay? One of the ways is we could say, all right, I'm looking to go from this side over to here. You know, that's what I've got this side I'm going over here, looking at that similarity relationship. And we could ask ourselves, what mathematical operation are we doing to get from x root 3 over here to x? Close, but also completely opposite of what you said.
Dividing.
Yeah, we're dividing, okay? So we are dividing by the square root of 3. So if you divide by the square root of 3, then you just get x. So therefore, we could divide this side over here by the square root of 3. There's other ways that you could have set this up. You could literally have written the proportion x root 3 over x equals 5 over a, and then done the cross multiplication. However you want to do it, we'll just say a now is going to equal 5 divided by the square root of 3. Does that answer good as is?
No.
No? What do we need to do?
Multiply by root 3 over 3.
Multiply by root 3 over 3. This process will result in us rationalizing the denominator. So straight across here, 5 times root 3 is just root 3. Root 3 times root 3. Root 9, which is going to be 3.
And that's it.
That is it for that final answer right here. I'll put it over here. 5 root 3 over 3. Can't get any simpler than that because 5 divided by 3, that's an improper fraction. It's also simplified. And square root of 3 is square roots, can't simplify that anymore. Just for fun, somebody want to tell me what this side over here would be, right? That hypotenuse? Think about how do we get from x to 2x? Multiply by 2. So let's take 5 root 3 over 3 and multiply that by 2. What do you got, Rosa?
I thought the smaller side was the x root 3.
No, the smaller side is the x.
Oh, okay.
This is correct, Ez. I'm pretty sure I wrote it that way yesterday. Now, yesterday the triangle orientation was like this, where the vertical side over here was the x, and this side down here was the x root 3.
Yeah.
But now it's been rotated around. That might be what you're thinking. So, all right, so anybody know, what is this sucker right here, 5 root 3 over 3 times 2 going to be?
10 root 3 over 3.
Yeah, 10 root 3 over 3. Just a little reminder for you. 5 root 3 over 3 times 2. Treat that 2 as a fraction. 2 over 1. Do your fraction multiplication straight across. 5 times root 3 times 2 is 10 root 3. 3 times 1 is 3. Anybody have any questions on that? Alright, I'm going to walk around real quick and check your answers on number 2. If you don't have number 2, go ahead and start working on that right now.
Still working.
Okay. Okay. They also have something 2.5 is a fraction. But they're equivalent. That's why I always draw the picture in the same orientation as this. And I just draw it on that
Should be
actual
the same for
paper.
you, would you flip it? I'm trying to put 6.
Yeah,
Why?
that's 169. Do 5 divided by.
Because you're supposed to cross multiply that.
Yes.
Do you flip it? Just choose. Ah, that's why it was working. But it would still be this. No? Would it be the other way? Oh, you didn't. Okay, okay. This is good. It's great.
So no shame in drawing the pictures there, right, as reference there. I think it really helps.
6 over B, right? It would be
Give you 30 more seconds.
So we can multiply that, flip it.
Yes. Yes.
Could you do it?
Are y'all three in agreement?
No, I think
Don't
it
worry,
works.
I always check one thing.
Yeah, it works. I got the same answer as you. Yeah, so it would still
That
work.
looks good.
I
That looks
did the same
good.
thing.
Yes, I agree with B. Yes, I agree with A. Okay, we're on the right track. I've seen some good stuff right here. Let's deal with this real quickly over here. Now, the other thing you can do is you can also label it on the actual triangle. So across from 30 degree x, 2x, and x root 3. Is that how? What do y'all think about that?
Yes.
That looks good to me. All right. Now, this is also tricky because we're looking for the x root 3 side, but they give us the hypotenuse. So we're going to have to do sort of like stop halfway, you know, get to this point right here, a little checkpoint, before we move over here. If you ask me, that's the way to do it. Anybody have an idea what this x side over here is? 3, because that's half. So therefore, this side right here is going to be 3 root 3. Very good. Final answer there. Now, if we look on this one, this is the x root 2, and this is the x side. Can you tell me how to get to the 45 leg? No. Where's she getting this stuff? All right. How do you get there, Ashlyn, from the x root 2 side to the x?
You divide by root 2.
Yeah, you divide by root 2. That's what you did. So we would say that a is equal to 5 divided by root 2. Let us rationalize that denominator. Multiply it by root 2 over 2, since it's 1, doesn't change the value, just change the way that it looks. Lipstick on a pig, still a pig. Final answer right here for A.
Oh.
Final answer right there for B. Some of you had 2.5
Yeah.
root 2. Guess what? It's the same thing. 5 divided by 2 is 2.5.
You said the final.
Yep, that'll all be good. Alright, I didn't change the font on this, but it's okay. Alright, so folks, back up here, class. So today we're going to do a couple things. The big thing is we're just going to do some problems that show that you know how to use sine, cosine, tangent. Okay? However, we're also going to learn a little bit more complicated Pythagorean theorem with the sine, cosine, tangent, and we're gonna learn 3 other trig functions, secant, cosecant, and cotangent. And we're
The
gonna do
opposite.
problems, all of those, and we're gonna finish before class ends. Oh, it's gonna be beautiful. Alright, here we go. So, real quick, give me a verbal reminder, the sine of an angle, oh no, y'all probably used to sine of x, right?
Yeah.
Well, I'm gonna change that. So here's the first thing to do, sine of theta, that's right. So that guy right there is theta.
Is that
It-
Greek?
It is Greek to you and it's Greek to me, and it's Greek to everyone, alright? Greek letter theta. Well, I mean, it's like B, you have to write B out, you have to write B, E, E. Although I read the other day, you know, for all we know, in like little honeybee, the B, the E's are silent.
Oh,
So think about that. Alright. What is that ratio for sine, folks?
opposite over hypotenuse.
Opposite over hypotenuse. Let's keep this train going here. Cosine theta is
Adjacent over hypotenuse.
adjacent over hypotenuse. Tangent theta, opposite, adjacent.
Adjacent.
Adjective.
Jake, and you get all kinds of variations on that one. Alright, so here you go. 3, 4, 5, and 6 as a table. Show what you know. Can you apply these facts right here? Should we do, let's do number 3 together first. Make it nice and easy. Alright, this is a right triangle has side lengths of 9, 40, and 41. Use these lengths to find sine L, tangent L, and cosine L. So what I always like to do is circle the angle that I'm dealing with, then go and label, ladies, the opposite, adjacent, and hypotenuse. Okay? What's the 9 gonna be there, folks? Opposite. What about the 40? Mm-hmm. And the 41? Which reminds me of one of my favorite public service messages here with the hypotenuse here. So built into the hypotenuse, even backwards, is a public service message for teens everywhere. All right? And that is, she knows, do not use any pot because it'll make you high. Alright? Right there, in Pythagoras, he knew it. Words of wisdom. Okay? So here we go. Sine L. I need to stop transmitting, then you know it's a joke here. Alright, so sine L, opposite over hypotenuse, call it out to me, class. What are those numbers?
You just want the fraction?
I want the fraction.
Okay. 9 over 41.
9 over 41. Okay? Now give me the decimal.
Oh, Hannah.
12.6.
Point what?
12.68.
On these works,
I'm not sure. I'm not sure if I'm doing it right.
I don't want the sine of 9 over 41. I just want 9 over 41.
0.2195.
2,
2195.
etc., etc.
Do you want us to write both the decimal and the fraction on their paper?
I want you to write the fraction because that's what Alex is going to expect. Alright, focus up here, class. One of the major issues, mental blocks that students have when they deal with sines, cosines, and tangents is when you do type sine of 15 or sine of 25 or 30 or whatever into your calculator, it's going to spit out a decimal answer. And so students tend to think that sine, cosine, tangent are decimals, and that is partially correct. But what you really need to be thinking about with sine, cosine, tangent is that they're not decimals, they are fractions, or I'll use the big word ratios. It's actually a smaller word, but it sounds a little more important. Ratios, they're ratios. It's the ratio of this over that, this over that. Now when you take this and divide it by that, you're going to get a decimal number. Okay, or you'll get a number with digits after decimal, most of the time, okay? So just keep that in mind. And we're saying it's the sine of angle L is equal to this. Let's keep going. Tan L, tangent of L, is opposite over adjacent. So 9 over 40. I'm sorry, I'm a little slow there. All right, there you go. And I don't care about the decimals at this point. Alex, is going to expect the fractions. And cosine is adjacent over hypotenuse, adjacent folks, 40 over 41. So they say use these lengths to find sine, tangent, cosine. That would be your answer right there. It'd be a 3-part question. And you'd have 3 answers. Okay? So now, as a table, I want you to take care of number 4, 5, and 6. 4 is with numbers, 5 and 6 are with letters. And compare your answers as a table. As you have answers, I can check them once your table agrees. Your table in agreement? All right, take your time.
No. It's so easy.
Check number 4. Good. Good. Feel free to attack that next one there. Ladies, are you all in one accord here? Alright, so lower jack here. Number 5.
I mean, if it's a right, if it's 45, 45,
Make sure line up here. Everything's looking good so far, okay? And so you're 2 for 2. No problem, no problem. By the way. Oh, thank you. Oh, okay. I only want to see pretty pictures here. So let's see, number 4. Sine, yep. Cosine, yep. I agree. Sine,
She's there.
good.
The overseas.
So, cosine, yep. Sine, yep. See if you can try this one if you dare. It's kind of tricky. How you ladies doing? I'm gonna check number 6 here. I'm gonna check here. Tangent. Yep. Cosine. Are you all in agreement? Have you compared?
We compared the last two. I finished
Okay.
ours.
Alright, we'll compare that one. Do you have number 6? Hold on a second. Cosine is gonna, you gotta mix up here. Just on the arrow. And that's what. We'll see that. All right. If I wasn't able to check all of yours, good news. Answers are on the back.
Oh.
Okay, how about that, huh? So if I'm not able to go around and check every single one, if I just check one of them, look and find the actual final answers there.
Oh.
Last page.
Oh, that's silly.
So, all right, let's go ahead. Ooh, number 7.
Oh, helpless.
This is gonna be a little tricky here. It says find tangent theta where theta is the angle shown. All right, no big deal. I'm gonna circle this. What am I gonna label the 4, folks? Opposite. And the 5? All right, and just for completeness sake, I'm gonna label this blank side over here adjacent. Then I shall write down the formula for tangent. The more I write it down, then the more I get it memorized. Tangent is opposite over adjacent. So opposite is 4. Got things good, they're going. We're gonna write the next part. Yeah, it slows down. Where is it? It's blank. Okay, so she's already getting it here. That's pretty much the answer all the time in this class. Pythagorean theorem. Yeah, we're gonna have to use Pythagorean theorem, or if you have this particular Pythagorean triple, which is everyone's favorite Pythagorean triple, memorize it, you can plug it in. We'll assume that you don't. And let's go and give it a variable name. Let's call it x. So, Ashley, volunteer yourself.
Oh, no.
What would be the Pythagorean equation I'll write down here?
A squared plus 4 squared equals 5 squared.
I'm going to call it x, just because I like that. So x squared is going to be 25 minus 16, so that's going to be 9. X is going to equal, take the square root of both sides, you get plus or minus 3. But since this is a distance, I'm immediately going to say, okay, it's not negative 3, positive 3. Hey, what do you know? It's everyone's favorite Pythagorean triple. 3, 4, 5. Y'all know that's a Pythagorean triple, right?
No.
Nick knew
I
it.
do now.
But
Yeah, I do now.
yeah, you know, not every set of numbers forms a triangle, and not every set of numbers forms a right triangle. There's only a specific set. And though that set of triples that are called Pythagorean triples, when they are whole numbers, all right, that can form a right triangle. 3, 4, 5 is one. 6, 8, 10 is another. In fact, any multiple 3, 4, 5 is. I think
Yeah.
I want to say 5, 12, 13. That's one of my favorite ones. I want to say some of the others, but I think they're on this. So anyway,
You already said something.
there you go.
Yeah.
So 4 over 3. And let's make it very clear. Be like Alex. Tangent of theta equals 4 over 3. That is the official answer for this problem. All right, any questions? This is using Pythagorean theorem in association with trigonometry. I think we can handle number 8. No need for us to do that one. Let's skip it, go down to this one. Find sine theta, cos theta, and cot theta. What in the world? What are these things? You guys, party crashers here, coming in and blowing up our sine, cosine, tangent, you know, greatness here. Well, these are the strange, awkward cousins of sine, cosine, tangent. Yes, just like cousins. They're kind of opposite. You know what I'm talking about? Does anybody have like a weird cousin? Or a cousin? Everybody does. Everybody's got those weird cousins, but you know, if you think about it from their perspective, you're the weird cousin. Yeah. See, they're like, yeah, she's in there like all those math classes, and carries around her MacBook. She's so cool, you know. Anyway, so Alright, so allow me to introduce you to the weird cousins, and they are completely weird in lots of different reasons, okay? In lots of different ways. So, sine is matched up with cosecant. CSC, pronounced cosecant. And it is the reciprocal
Oh,
of the sine. Hypotenuse
We
over
did
opposite.
this in.
See, I told you it's weird, it's flipped, it's upside down. It took you a,
It took you a sec.
so, alright, y'all are gonna make me think I'm funny, they're like, I am not that funny. I know I'm not. Alright, so, secant is the other one there. Once again, flip-flop stands on its head here, hypotenuse over adjacent. And see, everybody always thinks that cosecant goes with cosine.
Yeah, I just
That would
did
seem
that.
to make sense, but I told you, it's weird in like all these different ways, right? In fact, the only thing that's consistent is that it's weird, alright? But in factual fact, they all have a co-pair here. Sine and cosecant. Cosine and secant, tangent and cotangent here. Once again, flipped, adjacent, over opposite. All three of these are the reciprocal trig functions. Or trig ratios. We haven't really talked about this much. Okay?
This would be so time consuming.
No, so here we go. They want us to find, not all 6, just these 3. And you know what? I've got a feeling that I'm probably going to need to know what this other side is. At x. So let's get Pythagorean on this triangle here. X squared plus 15 squared equals 17 squared. Just a little bit of preventative medicine here. 17 squared minus 15 squared. Take the square root. X equals calculators. 8? I'm going to need a second on that motion.
Second.
Motion has been made and seconded. All those in favor of 8 say 8.
8.
All opposed say 9. No.
Can I get
Sorry.
a 9?
There's been German there for a second.
I got it. That
Alright.
was so good.
Alright, that'll be here all day, alright, all night, all week, whatever. Alright, here we go. So sine of theta is opposite. Oh, we got a. So I saw a little label here. Opposite hypotenuse and adjacent. I'm hearing voices here. 15 over 17. Cosecant. Double check that here. So it's hypotenuse over opposite. So hypotenuse over opposite. Yep. And cotangent. Adjacent. Just the 8. Over opposite. I agree with that. That would be the official answer on those. Alright, as a table, hold on, we need to see if there's an easy way to remember this like there was SOHCAHTOA. Let's see. So we've got cosecant is the opposite, or sorry, the hypotenuse over the opposite.
Cho.
So cho.
Oh, yeah.
Secant is the hypotenuse over
Shosha. Cow.
It's a cow.
Ow.
Just rolls off the tongue. Then they wouldn't show. Then it'd be incorrect.
Was anyone?
Oh, okay.
I
Like,
meant
oh.
like the order of like them, like
Ah,
as.
okay.
I-
Shakacho,
I was like,
something like that.
No. He was like, then this wouldn't be the thing.
Ka,
No.
if you can, Show.
Show
Chow.
Show your cow. That sounds good. You just have to get used to it.
Alright, while y'all are having fun there, go ahead and try to take care of number 10. Call me over when you get that taken care of.
Oh shoot. Ooh, this is tricky. Show your cow.
Wait, you have work yet? I'm already done. What? Oh, there's an audition?
Took a minute.
Oh, yeah, take an audition and jump in.
Y'all can work on some math stuff. We'll see. Just tune in here with the rest of the.
Really?
That's yours. Keep
Can
it.
you jump in? No, actually try it, because if you do the.
That's it. Thanks for watching.
Jump.